Okay, so we're going to do our normal distribution quiz review. We'll start with number 1. It tells me that using the curve below, shade the curves. So I want to fill them in. Shade the curves to represent the indicated situation. And number 1, I want to be less than 70. So I'm going to put P for the probability. We'll use that later. X is less than 70. This could also be said as no more than 70. So how are we going to do this out? I have an average of 80 and a standard deviation of 10. So 80 goes in the middle. I'm going to add 10 to the right because that would be above the mean. So 80 plus 10 is 90, plus 10 is 100, plus 10 again is 110. Starting at the mean going left would be below the mean. So when I subtract 10, I'm going to get 70, 60, and then 50. Seeing how it wants me to have less than 70, what's the probability when I'm less than 70? I'm going to put my line up at 70. And because it falls on a value already I've marked, I don't have to do anything with that. Just shade it in. So everything going to the left would be less than 70. Okay, let's move on to our next one. Clear this out. So for number 2, I have an at least. At least, so I want to have X is going to be greater than 75. Remember, later on we're going to need to know the probability of that, so let's put the P there now. So greater than 75. It's a good way to remember that. Everything else is the same. My average, my mean is still 80. My mu, my standard deviation or my sigma is still 10. So my number line in this case is not going to change until they change those two items on us. Actually, if either of those two items change, it'll change my number line. This time I want to be greater than 75. 75 is not one of our standard deviations away. So what I'm going to do is put my 75 here to show that I have 75, and greater than means to the right. Let's keep in mind that a less than symbol is here. It's pointing to the left. We shade to the left. The greater than symbol points to the right, shades to the right. So this is less than, greater than. All right, let's clear this one out real quick. Let's go move on to number 3. I'm sorry, number 5. I apologize. So now I'm in between two values. So I want to know, or I want to have my X between 70 and 90. Again, later we'll find a probability. It's the area under the curve. So all my other numbers are the same. 80, 90, 100, 110, 70, 60, 50. I want to know between 70 and 90, so between 70 and 90. All right, let's continue with B. The mean ACT scores for William Fleming High School is 30 with a standard deviation of 5 points. Determine the Z-score for the following students. Let's remember that your Z-score is your data value minus your average or your mean over your standard deviation. So for 7, my value is 37. My mean is 30. My standard deviation is 5. I'm going to get 7 over 5. And again, if you want to use your calculator, that's fine. So 7 over 5 is going to be nothing more than just 7 divided by 5, which will give me 1.4. So I have a positive number because it's to the right of the mean. Next we'll look at number 9. Number 9, now my new value is 22. So my new data point is 22. My mean is still 30. My standard deviation is still 5. I get negative 8 over 5. And for that, I'm going to get negative 1.6. It's negative because it falls below the mean. It falls below the average. and it's below the average by an amount of 1.6 standard deviation. So to get the number, you do 1.6 times whatever standard deviation is. You can see how far away it ends up being. Now to do number 11, we're going to interpret the following z-score in terms of standard deviation from the mean. So if I'm -2, I'm actually below the mean. By how much? Well, by 2 standard deviations. Let me abbreviate SD for standard deviation. Now, before we move on, I need to make a quick correction. I calculated out 1.4 for my answer for number 7, but wrote down 1.5. So did all that work and didn't write down the correct answer. I was not being careful enough. All right, so now we're going to look at 13 and 15. So this is in part D. So for the data follows a normal distribution. Let me try that again with words. A normal distribution with my average being 110 and my standard deviation being 10. So find the following. Find a probability. We're going to write probability with a P. The probability that the observation is less than 95. So X is less than 97. To do this, I need to have a lower bound, an upper bound. I need to know my average, and I need to know my standard deviation. So I know my upper bound is going to be 97, so I can't be any higher than 97. I already know that my average is 110, and my standard deviation is 10. Now, I don't have a lower bound for this. I don't have a start-off point. So if I'm missing a lower, what I'm going to do is I'm going to use -1 e to the 99. And this means -1 times 10 to the 99th power, or -1 followed by 99 zeros. Okay, if I'm missing my upper bound, I would write 1e to the 99, which is 1 followed by 99 zeros. In this case, I'm just missing a lower, so I'm going to write -1 e to the 99. Now to do this in our calculator, we want to make sure that it's on, of course. I'm going to go to second vars, or second variables, to the left of clear. I'm going to press the number 2, go down to 2. That's my normal distribution, CDF. So you can see I've already started off -e to the 99, -1, so I'm going to put that in -1. To get to e, it's second, comma. The comma is located right above the 7, 99. And then I'm going to put in 97. My average is 110, and my standard deviation is 10. Okay, I'm just going to hit paste. I have 0.960968. I'll always do 4 decimal places. Now I want the probability, so the probability I need to multiply by 100. So multiply by 100. That's going to give me a final answer of 9.68%. Do it in the calculator, just say multiply by 100. And that's going to be it. All right, so let's move on to number 15. Number 15, I want the proportion of observations that are greater than 125. So proportion, we don't need to multiply by anything. Last time, I multiplied by 100 to get a probability. So let's do 15. The proportion of observations between 98 and 118. Same thing though. So I have a probability. This time I want X to be in between 98 and 118. I must still establish my lower, upper, average, and standard deviation. Lower in this case is 98. Upper is 118. My average has not changed. It's still 110. My standard deviation is still 10. So there's no difference there. Same steps in the calculator. I'm going to have second variables. Button left of clear. Go down to number 2 or just press the number 2. My lower bound is now 98. My upper bound is 118. And I still have the same average. I still have the same standard deviation. I'm going to paste that in. Press enter to actually calculate it. It tells me it's 0.67 3. Now you can allow this 7 right here to round that 0 up to a 1. You can just truncate it and put a 0 there. Either way, it's going to be your answer. I like to circle my answers when I get them, so I would circle 9.68% and 0.6731. I would accept 0.6730 or 0.6731 if you truncate around, but I always want to see 4 decimal places out there. Makes life a little nicer. Okay, so this will be the last question that I'm going to go over with you. Okay, number 19. If the weights of Atlantic salmon are normally distributed with a mean of 10 pounds and a standard deviation of 2 pounds, how many salmon would you expect to weigh between 9 and 12 pounds out of 1,000 caught? So giving us a lot of information in just one sentence. I want to know how many are going to be between 9 and 12 pounds. So if I can find the probability of that, or if I can find the proportion of that, if I take that proportion and multiply by 1,000, I'll be able to tell you how many of those salmon that were caught were between 9 and 12 pounds. So I need to have the same setup. I need a lower bound, I need an upper bound, I need an average, and I need a standard deviation. So my lower bound in this case is 9, my upper is 12, my average, they tell me up here with a mean of 10, that's my average, my mu. And they tell me a standard deviation of 2. That's my sigma. So I'm going to go back over to my calculator. I'm going to go second variable. Go to 2. My lower in this case is 9. Upper is 12. I now have an average of 10 and a standard deviation of 2. I'm going to paste that in. Press enter. 0.53. 28. Now I still have to multiply by 1,000. When I multiply by 1,000, I'm just going to hit times and just put 1,000 in. The calculator knows that's 0.5328072082 multiplied by 1,000. I'm going to be left with my answer for this case, or pretty close to my answer, is going to be 532.8. Now we're not going to catch 0.8 fish, so I would have that round up. 533. 533 fish out of those 1,000 are going to weigh between 9 and 12 pounds. You should be able to finish out the rest of your sheet. Make sure you hand it in.